Hello everyone. Welcome back to our channel where we dive deep into the fascinating world of mathematics. Today, we will be discussing how math can help us understand the universe and reveal its secrets. So, let's get started. The Fibonacci sequence is a sequence of numbers that starts with 0 and 1, and each subsequent number is the sum of the previous two numbers. This sequence can be found in various natural phenomena such as the arrangement of leaves on a stem, the pattern of seeds in a sunflower, and the shape of shells. In fact, the ratio of two consecutive Fibonacci numbers approaches the golden ratio, which is found in many artistic and architectural designs. For instance, let's take a look at the pineapple. Did you know that the number of spirals on a pineapple follows the Fibonacci sequence? That's right. If you count the number of spirals on the pineapple, you will find that there are 8 spirals in one direction and 13 spirals in the other direction. And 8 and 13 are consecutive Fibonacci numbers. This pattern is not only found in pineapples but in other plants and fruits as well. The Fibonacci sequence also has interesting properties that are useful in various applications. For instance, it is used in trading and financial markets to predict price movements. In addition, it can be used to model the growth of populations and the spread of diseases. Let's take a look at how the Fibonacci sequence is used in trading. Traders use the Fibonacci retracement levels to predict price movements in financial markets. The retracement levels are calculated by taking the high and low points of a price trend and applying Fibonacci ratios to determine the levels at which the price is likely to retrace. Calculus is a branch of mathematics that deals with the study of change. It has two main branches, differential calculus and integral calculus. Differential calculus deals with the study of rates of change and slopes, while integral calculus deals with the study of areas and volumes. Calculus is widely used in physics to explain the motion of objects. For instance, calculus can be used to determine the velocity of a moving object at any given point in time or to calculate the area under a curve, which is the displacement of the object. Calculus plays a fundamental role in various fields such as physics, engineering, economics, and even medicine. For instance, in medicine, calculus is used to understand the flow of blood through arteries and veins. Calculus is also used in the design of airplanes, bridges, and other structures. In economics, calculus is used to study the behavior of markets and to determine the optimal production and pricing strategies for firms. For instance, calculus can be used to find the maximum or minimum points of a function, which can be used to determine the optimal level of production or price that maximizes profit. Calculus can also be used to model and analyze the spread of diseases. The rate of infection can be modeled using differential equations, which are an essential tool in calculus. In summary, calculus is a powerful tool that has countless applications in various fields. Whether it's analyzing the behavior of markets, designing structures, or understanding the spread of diseases, calculus plays a crucial role in our daily lives. Chaos theory is a branch of mathematics that deals with the study of complex and dynamic systems that are highly sensitive to initial conditions. In other words, a small change in the initial conditions can lead to a significant change in the system's behavior. Chaos theory can be used to explain weather patterns. Weather is a complex system with many variables that are difficult to predict. However, chaos theory can help meteorologists make better predictions by taking into account small changes in the initial conditions that could lead to significant changes in the weather. Another example of chaos theory is the butterfly effect. The butterfly effect refers to the idea that a small change in one part of a system can have a significant impact on another part of the system. This idea is often illustrated by the example of a butterfly flapping its wings in one part of the world, which can ultimately lead to a hurricane in another part of the world. Chaos theory has applications in many fields, including biology, economics, and engineering. In biology, chaos theory can be used to study the behavior of populations of animals or cells. In economics, chaos theory can be used to model the behavior of financial markets. In engineering, chaos theory can be used to study the behavior of complex systems such as aircraft or bridges. Chaos theory has also inspired the development of fractal geometry, which is the study of geometric shapes that have self-similarity at different scales. Fractal geometry has applications in many fields, including computer graphics, art, and architecture. Cryptography is the study of codes and ciphers, which are used to protect information and ensure privacy. Cryptography uses mathematical concepts such as number theory and algebra to create codes that are difficult to decipher. Cryptography is used in online transactions to ensure the security of the transaction. When you make an online purchase, your credit card information is encrypted using a code that only the merchant can decipher. This ensures that your credit card information is not stolen by hackers. In addition to online transactions, cryptography plays a vital role in securing communication and protecting sensitive information in various industries, including military and government. Cryptography is used to encrypt classified information and protect national security. During World War II, cryptography played a significant role in military communications. The German military used an encryption machine called Enigma to encrypt their messages. However, a team of code breakers, including mathematician Alan Turing, worked tirelessly to crack the code and help win the war. Today, cryptography has evolved to include various encryption methods, including public key encryption, which uses two keys, a public key and a private key, to encrypt and decrypt information. This method is widely used in secure online communication and e-commerce transactions. Cryptography is also essential in ensuring data privacy and security in the digital age. With the rise of cybercrime and data breaches, organizations must use robust encryption methods to protect sensitive data from hackers. One example of cryptography in data security is the Advanced Encryption Standard, AES, a widely used encryption method to protect data stored on computers and other devices. AES uses a block cipher to encrypt data in blocks of fixed sizes, making it challenging for hackers to break the code and access the data. In conclusion, cryptography is an essential part of modern-day communication, e-commerce, and data security. Without cryptography, sensitive information would be vulnerable to theft and exploitation. By using mathematical concepts such as number theory and algebra, cryptography provides a secure way to encrypt and decrypt information, ensuring data privacy and security. Game theory is a branch of mathematics that deals with the study of strategic decision-making. It is widely used in economics, political science, and psychology to explain the behavior of individuals and groups in different situations. Game theory can be used in economics to explain the behavior of firms in a competitive market. In a competitive market, firms must make strategic decisions on how much to produce and at what price. Game theory can help firms make better decisions by taking into account the behavior of their competitors. Game theory is based on the idea that individuals and groups make decisions based on their own self-interests. It assumes that individuals are rational and try to maximize their own payoffs in any given situation. The theory involves analyzing the strategic interactions between individuals and groups to determine the best possible outcomes. One of the most well-known games in game theory is the prisoner's dilemma. In this game, two prisoners are arrested and put in separate cells. They are given the option to either betray or remain silent. If both prisoners remain silent, they both receive a light sentence. If one prisoner betrays the other, the betrayer receives no sentence, and the other prisoner receives a heavy sentence. If both prisoners betray each other, they both receive a moderate sentence. The prisoner's dilemma is a classic example of a game where cooperation would lead to the best outcome for both parties, but the incentive to betray is strong. This game has important implications for decision-making in real-life situations, such as negotiations between countries, business deals, and environmental agreements. Another important concept in game theory is the Nash equilibrium, named after the mathematician John Nash, who won the Nobel Prize in Economics for his contributions to the theory. The Nash equilibrium is a situation in which no player has an incentive to change their strategy, given the strategies of the other players. It represents a stable outcome in a game where all players are rational and have complete information. Game theory has a wide range of applications, from economics and politics to biology and psychology. It can be used to analyze voting behavior, social networks, and the behavior of animals in nature. It has also been used to explain the evolution of cooperation and altruism in human societies. Hello everyone. Welcome back to our channel where we dive deep into the fascinating world of mathematics. Today, we will be discussing how math can help us understand the universe and reveal its secrets.